Each week, a group of educators and mathematicians gather to experiment whether a certain puzzle or problem is going to be good for the math classroom. This week, Asmita introduced us to Pentomino Sudoku. There are 107 ways for a 5 by 5 square to be tiled with pentominoes. Here they are. Of course, you could rotate each of these or flip them around, but there's really 107 different ways to do this. Of course, that makes for a really interesting Sudoku variant. Is this a solution? Well, like with Sudoku, there's certain rules. First of all, we know that every shape can have exactly one and only one of each number. So this fails because the red shape has 2 3s. It also fails because, like in Sudoku, you can't have any row or column that has duplicates. So here we fail because this column has got 2 2s. In this puzzle, I've given you 5 hints. Is it possible to solve? I don't know. I actually haven't solved this one. So the options are it's solvable and there's exactly one answer. It's solvable and there are many answers. Or it is impossible to solve. First of all, I'd like you to consider what are the fewest number of clues that you can give that make a puzzle impossible. Well, the really interesting result is that the answer is 0. This one is impossible to solve, no matter how you put in those 1, 2, 3, 4s and 5s. Asmita discovered this during our meeting yesterday. Vince then found that this one is also impossible to solve. It doesn't matter how few numbers you have to start with. It's always impossible. This one here is... now I want you to think. If you give 5 clues, I'll tell you that this is possible to solve this one. But is it possible to do it with 5 clues? For any 5 clues, to find a unique answer? And the answer is, of course, no, because you could have ones like this. Well, of course, that's not going to give a unique answer because your 2s and 3s are interchangeable. So, of course, this won't give a unique answer. This will either give many answers or no answers. Okay, all of these are either going to give no answers or many answers. Here's an example of one that's going to give no answers because the red one is automatically a fail because you've got 2 1s in there. This one here, same thing. Either you're going to have many answers or you're going to have 0 answers. You will never have a unique answer for one of these puzzles. That's interesting. Okay, so now what I want to ask you, what are the most clues that you can give? Let's say that you choose your clues really, really badly. What's the most clues that you can give someone so they still don't know the answer to a puzzle? So I want you to think about that for a while. And the answer is, I'll give you a clue. The answer lies in this. This is a solution. Everything works here. Okay? But now I want you to imagine taking away clues. Imagine that you're taking away clues. What are the fewest number of numbers that you can take away and the person still doesn't know the answer? Well, of course, if you look in the bottom right, that square there, you can figure out that if we remove those, there's no way to tell which of those 2 solutions we have. So I'm just going to remove those. There is a puzzle with 21 clues, and you still don't know the answer. There's 2 answers that I have in mind, and you don't know which one I've chosen. That's interesting. Okay, this was discovered by Vince, and it is a joyous, interesting canvas. And why is it so interesting? You know that most of these canvases, they require 5 hints in order to solve. This one only requires 4 to find a unique solution, but you have to choose those 4 carefully. So why don't you take it, second here and think, where would those 4 go? Maybe there's multiple places that those 4 could go, but I'm going to show you one place that they could go, and then we're going to solve this puzzle. Ready? Here we go. There we go. Those are the places, and with just those 4 clues, you're going to be able to solve this entire puzzle. Of course, you can never find a unique solution with just 3 clues, because the 2 numbers that you have not chosen, they're interchangeable. Okay, so this is guaranteed to be an example of the minimum number of clues that you need to solve one of these canvases. What do we know here? Well, first of all, that has to be a 3. You can figure this out as we go. I'm not going to spend a long time on each one. We also would know that that is a 4. Think of why that's true. That's going to be a 3. So we have lots of ideas here. Okay, go ahead. Tell me why I've highlighted that square. What do we know about that square? I'll give you a hint. Consider the 3s. Okay, what do we know about that square? It has to contain at least 2 3s. No, it has to contain exactly 2 3s. Okay, so how are they oriented? Well, they can't be oriented like that, because then the blue region has got 2 3s. So they have to be oriented like that. Okay, that means that has to be a 2. Why was that? Why did that have to be a 2? Oh, because otherwise there'd be a 2 2s in that central column. Okay, I believe that. Now, what else do we know? Well, that has to be a 5, because it can't be a 1, because we already have a 1 in the brown shape. Okay, that means that is a 1, and we are filling this in quickly now. Isn't that beautiful? What a beautiful puzzle. There is an existing copy of this out there. This is from Think Fun, these type of puzzles, and it's out of print right now, I believe. But that is such a joy to play with this puzzle. Take care.